Okay, let's look at some review questions of chapter 18. Forces in a fluid. 18.1. What are the three basic types of stress? Okay, well, they're tensile compressive, that's one type. Then the other type is shear, and then the other type is bulk. Okay. Describe the forces involved in each one of these. Well, tensile compressive, you just have an object where if it's tensile, you're stretching the object. If it's compressive, you are shortening the length of the object, you're compressing it. Shear stress, if you've got an object there, you apply a force in that direction and a force in that direction, and it causes the object to change shape into this kind of shape. So you're applying a shear. And then bulk means we're applying force on all of the surfaces. Okay, on all of the surfaces. So make sure that you understand that. 2, what is the difference in how non-viscous liquids and viscous liquids react to shear stress? Okay, non-viscous liquids and viscous liquids. Non-viscous liquids cannot resist shear stress, cannot support shear stress. Viscous liquids can support shear stress. Okay, examples of these are water, gasoline, ethanol, mercury. And viscous liquids can sustain shear stress, and examples are jelly, tar, molasses, and honey. These are some examples. 3, describe the difference in how gases and liquids respond to bulk stress. Remember, bulk stress, there's pressure on all of the surfaces. Okay. Well, gases are compressible. They're compressible. And liquids are incompressible. So as you apply a bulk stress to a gas, its volume is going to get smaller. So its volume will get smaller and its density, its mass density will increase. But liquids are incompressible, so its volume and its mass density will remain the same. Okay. 4, what is the relationship between force and pressure? Okay, well, we know that pressure equals force divided by area. How are the two different from each other? Force is a vector, pressure is a scalar. Okay, and another way that it's different is that for the very same force, if you change the area, you'll change the pressure. So a larger area will give you a smaller pressure. A smaller area will give you a larger pressure for the same force. 5, what effect does Earth's gravitational force have on pressure in a fluid at rest in a container? Well, the deeper you go, the higher the pressure is. Okay, and so it's got this linear relationship. So the gravitational force exerted by Earth on the fluid causes the pressure in the fluid to be greatest at the bottom of the container, and it decreases with height. As it goes up, the pressure decreases. 6, how does a pressure change applied to the top of a column of liquid held in a closed container affect the pressure throughout the liquid? So you've got this container and you apply a pressure and you change the pressure at the top. How does it affect the pressure throughout the liquid? Well, that pressure change is transmitted right throughout the liquid, the pressure change. Okay? It's transmitted equally to all locations throughout the liquid, and this is called Pascal's principle.